Hi guys, and welcome to the ACE Academy. In this video, we are looking at calculating the number of moles. Now, in the previous video, the introductory video for the series, I explained to you that number of moles is simply a term given to a set number of particles. A scientist back in the day called Avogadro figured out that 6.02 times 10 to the power 23 particles of any substance is equal to 1 mole of that substance. It's like saying 12 eggs is 1 dozen of eggs. It's a ratio that we have given a name to. Now, in order to calculate number of moles, we have a simple formula that we use, and that is the number of moles of any substance is equal to the mass of the substance in grams divided by the molar mass of the substance. Now, in the introductory video, I taught you guys how to calculate molar mass, and when it comes to mass in grams, that will either be given to you or you will need to find it. Now, the reason why this formula works is simply because the molar mass of an element is the mass of 1 mole of that substance. So, if I am dividing the total mass of the substance present in the system by the weight that 1 mole of that substance would have, I would obtain the number of moles of that substance present in the system. It's simply ratios. We have a little exercise for us to complete together in order to reinforce the bit of theory that I have shown you. The first question asks us to calculate the number of moles of 16 grams of sulfur. Now, 16 grams of sulfur, that is an important part of the question. It tells us the mass in grams of sulfur present in the system. We can simply use the number of moles formula, which is N is equal to mass over molar mass, and in this case the mass is 16 grams divided by the molar mass of sulfur, which is right here, it's 32, and we would obtain the answer of 0.5 moles. So the number of moles of sulfur present in the system when 16 grams of sulfur is the mass is 0.5 moles of sulfur atoms. Quite simple. Let's calculate the number of moles of 100 grams of carbon. Exact same procedure. Number of moles is equal to mass over molar mass. The mass value is 100 grams. The molar mass of carbon is 12. So 100 divided by 12 should give us 8.33 moles. That was a bit repetitive. We just did the same procedure that we did in the first question. Simply substituting in a mass value into our formula, obtaining the molar mass from our periodic table, and simplifying the equation until we obtain our unknown, which was number of moles. Let's look at the third question that we are going to attempt together, and that asks us to calculate the number of moles of 20 grams of NaCl sodium chloride, which is your table salt. Now, in order to calculate number of moles, we of course need the molar mass of the substance we are working with. Let's look at the information that was given. We have the mass of the substance in grams, we have the substance itself, but we do not have the molar mass of the substance, which means we have to calculate the molar mass of the substance first. So molar mass of NaCl is actually the mass of sodium, Na. So the molar mass of sodium is 23, and we're going to add that to the molar mass of chlorine, which is 35.5, and we would obtain a molar mass of 58.5. Now that we have the molar mass of our substance, of our molecule, which is 58.5, we can go ahead and calculate the number of moles present in the system. That is done using the number of moles formula, which tells us the number of moles is equal to the mass in grams over molar mass, which in this case is equal to 20 divided by 58.5, which is equal to 0.34 moles. It was quite simple, guys. That just tells us that in order to calculate number of moles, we of course need to know the molar mass of the substance that we're working with. Let's look at question 3. This is a new type of scenario that we haven't worked with yet. This question tells us that there is 200 grams of an unknown substance X in a container. The number of moles of the substance present in the container is 8.69 moles. What is the symbol of substance X? So the information that they have given us in this question is the mass of the substance present It tells us how many moles of the substance there are for that mass, but they have not given us the substance itself or the molar mass of the substance. This means that in order for us to find the unknown substance X, we would have to calculate the molar mass of the substance. Let's go ahead and do that together. Using the formula for number of moles, we get number of moles is equal to mass over molar mass. We need to find molar mass, so we are going to rearrange this formula. Let's multiply both sides by molar mass. We'll get molar mass times number of moles is equal to mass in grams. And let's isolate molar mass. To isolate molar mass, we'll divide both sides by number of moles. We're going to get rid of the number of moles on this side. So we would get molar mass is equal to mass over number of moles. Let's go ahead and apply this formula in order to find our unknown. We know that the mass of the substance is 200 grams, so we can put that in. We know that the number of moles present of this substance is 8.69 moles. Let's go ahead, simplify and calculate to obtain 23.01. So we know now that the molar mass of the substance is 23.01. Let's go ahead and grab our periodic table. Looking at our periodic table, we now have to find an element that has a molar mass of 23.01. This is quite simple. We can see that sodium has a molar mass of 23. So that means that our unknown element X is equal to sodium. And we have now given the symbol for the element that we have found. Our answer is completed. We have solved the question. Keep on practicing, guys. That's it from me. All the best, and I will see you in the next one.